Good morning. So by show of hands, how many of you noticed on the board outside that McAfee is misspelled? Okay, this is very disappointing when we talk about data governance and Lineage. But also by show of hands, how many of you in here have been to another session in this room on the enterprise track? Awesome, a fair number. So in other words, you're the gluttons for punishment going for the really long session titles. So this session has the longest title by character length of any session here. Sorry about that. It's a long, verbose title. But let's go ahead and get started. So once again, David Newell from McAfee, Jeff and I are working on building out our new data platform for the consumer business unit at McAfee. And that comes with a lot of data, since if you have bought a new PC in the last few years, it probably came pre-installed with McAfee. That's the product that we work on. And so that comes with, as you can imagine, so many new devices, lots of data that come with it to understand how users are using the product, how we can better market to them, how we can also better protect them, keep their devices running smoothly and without threats. And as we've looked at modernizing our data environments, we've seen a lot of things around the challenges of big data. And these are all things you probably have heard before. First is just in figuring out what's important in the data. So you have so much information. How do you make sense of it all? And if you're like me, you probably have lots and lots of emails. You're getting instant messages, text messages. I find it a bit of a challenge just to figure out what's important. Also around big data is it's often challenging to find the skills that are necessary to process it, to analyze it, and especially to keep it clean. And we'll talk a lot more about that. Third, as you've seen at this conference, technology is moving really fast. And as I was hearing last night, Databricks has had huge explosion in the number of customers they have, and they're making huge advances in developing this technology. And so how do you keep up with it, especially with limited resources? And then finally, if you're anything like McAfee and you probably have multiple data silos that pulling that data together, wrangling it so that you can be productive, building models, analyzing that data can often be very challenging. And at McAfee, we started out with a lot of these same challenges. So first, we had a bit of a challenge where we didn't necessarily know what the data meant. And so our engineers would start sending up an event tracking some kind of activity in the product. And as you go around and we would ask like 5 different people, we'd get 5 different answers. So you can imagine from a data governance, even just figuring out how do I use this data? How do I make inferences off the data? That's a big challenge when you get different answers to what does this data mean overall. Second, we also had limited data science and data engineering roles and skill set in the organization. We even, as we look at lineage and governance, we're like, we need some kind of data steward or a data governance manager role. Karuna up here is playing that role for us. We had to go to HR and say, we need a new title. We didn't even have a title that described this particular role. And so, again, we had those kind of challenges as well. Our current systems are based off of a foundation that's 15 to 20 years old, which, of course, with technology moving faster, it's like, well, we have to, even just transforming that data, manipulating it can be a bit of a challenge. And then finally, of course, we had multiple data silos, and one of our biggest challenges was that most of these couldn't talk to each other. They were entirely segregated on the network. And so you couldn't even access your data from one place. You had to go into like 3 different jump hosts, pull the data out, join it together, and that's if it was small enough to fit on your local hard drive. And in many cases, we just found that was not feasible. And so as a result, most of our analysts were like this. They're like, I don't even know where I can get started. And so we set out to build out a new platform, essentially, and to ultimately drive self-service analytics. So today we generally have more of a service provider team that fields requests, goes off, figures out how to put together that data. and then produces reports and analyses and dashboards. And it's great, but we're essentially limited by the bandwidth of that team. And as we want to drive a greater data-driven decision-making culture, we need access to data faster and to be able to scale that out through the organization. And so our primary approach is to drive self-service so that we can make data part of every user's daily workflow. So whether it's in software engineering or product management or even into our marketing organization, we want to enable all of those functions with data. And in order to do that, we're aiming to, of course, get to all sunshine and rainbows. But first is by pulling all this data together, creating a comprehensive customer 360 so that we can understand how users are using the product, when they've received messages, so that we can do a lot more analysis off that data. But this requires pulling in multiple data sources into one place. And as you might traditionally do in a data warehouse, but at a much higher scale. As we were talking about 250 plus terabytes of data, we are currently ingesting well over 1.7 terabytes per day, and upwards of 800 million to 1 billion events per day. Lots and lots of data, of course. But second is, how do we make those calculations and analyses accurate? And this is where Jeff will talk a lot more about how do we make sure that we know how the data is processed, how it came to be, and track that lineage back into the source. And so that way then you know, hey, I'm confident that this data is right, I know where it came from, and so I can then make the right decisions off of it. So any nuances are clearly identified. Next is it has to be easy to access. I talked about the challenges of getting access to data. And so this is where Databricks, and in particular Azure Databricks, has been very, very helpful for us, is in enabling users to access the data from their local PC backed by tremendous compute power. Moreover, in Azure Databricks, it's directly integrated with our Active Directory. And so as we log into Office 365, the same way you're single signed on into Azure Databricks out of the box. It was incredibly easy to set up. And then finally, in our current data or current and historical data environments, it typically takes a little while to get data on the scale of a few days, typically lag to get the data. And so we're looking to accelerate that process and get data at least on a daily, if not hourly, or even up to the minute basis. And we'll talk about how we use Databricks to do that. Jeff will take you through how we made it happen.
Thanks, David. Okay. So we had to make the change with the announcement of Delta Lake. So this is now the Delta Lake fallacy instead of the traditional data lake fallacy, which has been published a few times. The data lake or the Delta Lake, it's not a silver bullet. It's not magic. You have the goal of pulling in data from many different systems. These systems can be legacy. They may have been written by someone who left the company years ago. Lack of documentation, lack of understanding, lack of joinability across these systems. And when you start pulling all of these different data systems into one data lake, you get the benefit of, you can probably join stuff across these systems better. But the idea of the clean data lake, or is it more of going to become a data quagmire, which if we had gone down this path, this is exactly where we would have ended up. Your data lake is still dependent on the veracity or quality of the data coming in. You still have the same volumes of input. So if that data was dirty in the first place, it's still dirty, and now you have more of it because you now have all of these systems coming in together. And extracting value from that is still a skill set item. If you had trouble extracting data from a single system, is it going to be any easier to extract it when you now have 10 times or 100 times the amount of data and complexity associated with it? So how do we keep the data lake clean? The first thing we worked on is a portal for systematic data governance. We wanted to have comprehensive data documentation. When an event comes in, we want to know what it is. We want to have a good description that a new McAfee employee can look at it and go, that's what that event means. Validation rules. So if an attribute coming in with an event is supposed to be 1, 2, or 3, if there's a 4, we want to know about it, because without those validation rules, you can't enforce data quality, and you can't enforce that the documentation gets fixed when something changes. And honestly, my personal favorite is event ownership. When you see issues, you have a product owner who understands what this event is being used for, and an engineering owner that enforces, the engineering team or the lead to go back to get things fixed, or to ask questions if you don't understand specifics about this event. So what we ended up doing was building a centralized data governance system where we enforce events do not leave the system until they pass certain data criteria. I'm just going to go through a simple use case. Think of a developer wanting to implement a new event. Let's say product uninstall. We want to fire off an event so that we understand when people are launching the uninstaller. The developer goes in, writes the code to add in the analytics event, and they're done. And hold on a second. We don't know what that is. We don't have no way of tracking it. So the system we've built enforces that the developer implements and writes documentation for these events. So it's actually a documentation portal that generates configuration files that are used by our analytics system. The data will not make it into the backend until documentation exists, and even the quality of documentation needs to be audited and approved. There's an approval process to ensure that these documentation criteria meet certain levels. So data is cleaned at the source. Now, an extra side benefit of the system is we've also been able to add in a privacy layer, which can do things like stripping out potential PII at the source automatically. So if this new developer doesn't know what he's doing, accidentally pulls in a field which could be considered PII from the system, that data is going to get processed locally before leaving the system to ensure that we're not sending something up into our cloud that could be considered PII down the road. Because the last thing I want to do is have to start going back and ETLing through petabytes of data to try and strip out PII information that was accidentally sent in there. So now that we've got good raw data into the system, that's a good start. But then the complexity becomes ETLing. How do we track that system? So we built a similar process on top of the individual raw events. We built a data-driven pipeline. So all of our ETL jobs are using the same process. They're configuration-driven, and the configuration is documentation-driven. So with every ETL, there's documentation defining what this ETL is for, the process, which events are going from one side to the other, each of the attributes and the transforms associated with it. It's actually a similar idea to Arrow, which I'm sure most people in the audience have heard about. But this enforces the Lineage governance. So with the end-to-end flow and visualizations, now when you go to a table within the system, you can drill down. Not only can you see where this field came from and trace the ETL back, but then that can also trace back from the source data the definition of what that event and the attributes were in the first place. So this works extremely well for understanding data, but it also allows us to understand the flow the other way. So when a poor developer is asked to make a change within the ETL flow, when he goes to make the change, he can see upstream implications and understand, if I make a change here, it's going to affect all of these tables going the other direction. And with owners assigned across that flow, you can now go to each of the ETL owners for those tables or the reports that it's going to affect and understand if it's going to affect them. And also, if that's going to affect them and there's a change that needs to happen, you can notify. So you don't get a phone call from your CTO or someone in finance saying, hey, this number just changed yesterday. What happened? You can get ahead of that and understand how that's going. Brief view of the architecture where this has been laid out. We've gone all in on Azure with this. From the left side are anonymized data sources. That's the piece I was talking about with our data governance process, where data does not leave the system until it's hitting the data criteria. That system of events are fed in through Azure Event Hubs, which is a fantastic PaaS-based solution. The events are streamed directly into Databricks Deltas, which allows us to handle real-time data flowing in. It also allows us to do things like real-time joins, and also do ingestion and data quality analysis on that data as it's coming in. That data is stored in Azure's Data Lake Store, which is a fantastic system, allows for AAD authentication at a very granular level. We then also have the ETL system from the raw data that processes on a minute, hourly, daily, weekly basis to generate those aggregate reports that are so important to run the business. And those ETL reports and jobs are all using the data lineage system that I talked about. And we're actually using Azure Databricks to host as a data warehouse as well. So we don't have a separate SQL data warehouse sitting on top of the data. We're using the same system, and we're simply having MicroStrategy, Power BI, Tableau, basically tool of choice that can connect into it and generate the reports. And that way, having a single system, you're enforcing your single data governance. But it also empowers our data scientists to connect in with RStudio, even Excel if they want, to be able to look at that data. So what were our big lessons learned when we were going through this process? Don't compromise on data quality. You are going to regret it later. Anytime we took that opportunity to move something faster, and it's like, oh, we'll just let this by once. It will come back and bite you. It may not be tomorrow, it may not be the next day, but it will come back and bite you. And the longer it sits in there, the longer that bad data sits there, it multiplies. So just don't do it. Create small manageable features. Increment. Build out your user stories and incrementally put these pieces together. Don't try and build the entire system all at once because you may not understand all those use cases. So bite-sized pieces, show value, and think ahead when you're building these things. Just don't do things that are going to handicap you in the future. And this is essentially repeating the first case. Make sure that you understand the data, make sure that you understand the quality associated with that, and understand how it's going to be used. So just going to finish here. At the heart of all AI technology is data. And that basically sums up why we're all here. We're trying to make insights from all of these data processes, data sources, and if the data is wrong, you are lost. And one more thing, don't compromise on the data. You will regret it later. Okay. Thank you very much.
So I think we've got plenty of time for questions.
For questions, we have a microphone here on the far corner over there, as well as a microphone over here on the side for any questions you may have. So I guess I'll cede for the first question. It sounds like you've been bit before about not letting data into any amount into the data lake and making sure that you're maintaining the quality of that. Can you elaborate a bit more on, I guess, how you learned that lesson?
I can't go into entire specifics, but I can tell you within our systems, we have ran into that where without understanding the implications of where the data is flowing to, small incremental changes that were thought to be innocuous started showing problems in reports a year later. Because within our systems, especially our core consumer suite, they ship on OEM devices, which will often have a year runway between us giving it the product to, say, Lenovo or HP, and the machine's coming out the production line. And it's not a quick switch. It slowly ramps up. So the one case I'm thinking about right now, a change was made in the product, everyone thought it was fine, and a year later, one of our key metrics started to shift. And it took months to trace back why it was shifting. And I can say there were probably, I probably burned 200 or 300 hours myself, personally, trying to dig into this, not to mention my teams.
And I'll expand on that with another example of when I first joined McAfee a little over 2 years ago. One of the first things I wanted to do was understand things like virus scans, and it was you may, if you're familiar with McAfee at all or virus scans, there's both automated scheduled scans and there are those manual run a scan now type of situations. And we tracked it simply with a field that I thought was going to be really good that's called user initiated. And if you're like me, you were probably thinking, oh, it's going to be true or false. We went and looked into the data and we're like, okay, we see true, false, 0, 1, and 2. If any of you know what 2 is, please let me know. Find me afterward. But that's one of those examples. Before we had these validation rules in place, and it just accumulated over time and just grew and got worse and worse and worse, and led to the fact that our product management team couldn't understand how features were being used.
Glad to hear. Now, I'll step away. And I know you've been one of our early Delta Lake users to help address some of these reliability concerns. It sounds like that helped with making sure you didn't get 2s in your data as often.
I think one of the key points there was by validating it before it even came in, since we're like, wait, expectations isn't there yet, we just cleaned it at the source to begin with, so we don't even get bad data coming in to the Delta Lake.
So I have some questions. So one is, you said you have a structured streaming, Spark, right? Clusters. Do you have to keep that cluster always on, in terms of cost? Because what I was told is, you just use it only when you need it and then kind of shut it down or something. Like you have the event hub, Kafka equivalent, right?
Yeah.
Because we are considering that. Do we always keep it on or just use it sparingly?
Yeah, so how do we handle cluster management and particular streaming and the interactive jobs for the 2 different roles?
Yeah.
You want to take that one?
Okay, so for the structured streaming, we do keep a stream running all the time for our main lines.
Okay.
The ones that are high volume,
okay,
and we want to get the access to the data in real time.
Okay.
But one of the nice things with event hubs, it will queue up data for up to 24 hours. So for some of our other streams where we don't really care about the real-time data, we'll fire up a cluster 3 times a day,
okay,
where it will pull the back queue in, stream it into the table, and shut back down again.
So that little bit latency is okay, from your reporting, right? Then,
and then on our analytics platform, which is an interactive or formerly known as serverless cluster, we have it auto-scale, and so we have it always on with at least 1 worker, and then scales up as load increases. And it seems to work reasonably well.
You said the Power BI, Tableau, and all the stuff, right? Mm-hmm. Typically, let's say Elasticsearch, sub-second latency they're used to seeing in the dashboards. In Databricks, I talked to them, they say only seconds latency they can provide. Sub-second, they recommended either Redshift or in the case of Amazon, or Elasticsearch or Tableau or something. So do you keep a cluster on, or do you just copy it each time and then push it to Tableau or something?
So at this point, question around BI performance with the interactive cluster. And from what we've seen so far, there's varying levels of query performance. It's pretty much directly correlated to how much data is being queried. Okay. I think we're still tuning that quite a bit and trying to boost that performance. Okay. But we do see that when you're querying over all the data, sometimes it does take a couple of minutes, but typically your second query runs way faster than the first
cache
one.
Warming, I get that. And then this is the dashboard getting updated near real time, meaning every streaming, so today I update the dashboard. The next day you have an incremental delta coming in, right? Do you do an A/B, you have a temp table in the dashboard, you just create it from scratch, and then do you switch over swap, or do you keep updating the same dashboard by an append only or some kind of a same index or something?
Yeah, so how do we update the data set that then powers those dashboards on a regular basis? Do you want to talk about how that we structure that?
Yeah, so in general, a dashboard where it's going to be a rather complex calculation, we have hourly or daily ingest ETL jobs. So within the ETL pipeline I mentioned, where it's configuration driven, there'll be a configuration to generate a view or a table that can be used for that dashboard. Now, it may not be specifically for that dashboard. It may be a general purpose table that's calculating, say, a particular set of aggregates. Now, you could use Tableau and go back to the raw data and query the entire thing, but it's going to be slow. So what we ended up doing to start with was we started creating the ETL pipeline with everything being views, and then we were analyzing user behavior and analyzing how they're being used, and then started flipping them on to being pre-calculated aggregates to improve performance where it needed to be improved.
Sure. Okay. And one final question in terms of rules and lineage, right? Do you have to audit somewhere? Meaning, I'm transforming from one DF to another DF to another data frames, and these are all the audit changes that I did, or was it just for validations you have a governance?
So,
Because I can have one notebook with multiple DFs, like one to another transforms.
yeah.
And I can do it
Yeah,
in
so
bulk.
how do we track the custom calculations that we've
we
coded
have a
into
use
the
case
ETL
wherein
pipeline?
every transformation we have to record it. We have to say, I am
Yeah.
changing it from this to that, right?
Yeah, yeah.
So how do,
That's in the configuration files that are generated from the portal itself.
okay, thank you.
Yeah, so essentially our configuration-driven pipeline starts with a configuration file that then generates all of the transformation logic. And so essentially we can take that same configuration file and say, hey, here's the visualization of the lineage. So, yeah.
Yeah.
Oh, question.
Yes, in the architecture, you have shown us the data catalog. Can you let us know like how you are using the data catalog to capture the metadata in the data lake? How you are capturing it and how you are preserving the lineage of that?
So how are we using a data catalog?
Yes, to capture the metadata.
So that the systemized portal for governance essentially can serve in most cases as our data catalog because we've already documented all of the events that we track and the entire lineage through that. We can then essentially just say, here are all the descriptions on the different data, on the different fields and so forth. However, we are also working on pulling some of that data back into Databricks so that it's like database comments essentially. Comments on each field. Did you want to add anything?
Yeah. Well, from a roadmap perspective, we have lots of things. David could probably talk to that for another hour. On
Absolutely.
He wants to be able to tie the data governance back into the data itself, so that you have a full cataloging system as well for discoverability.
For example, let's say like I have a CSV file which shows like different. We are capturing the headers. Do you capture like that? If you wanted to capture like we might have a different for data lake files, like we might store it. So how do you capture it? Are you able to capture the headers or manually feed it?
So before the data will be ingested in, you need to create the configuration file that defines that it's going to be coming in from the source. And these are the attributes that are going to be in the source. Here's the description for each of the attributes. Here's what a row in that CSV file represents. So we're enforcing that up front, where the file will not be ingested into the system until you have created that documentation, because by creating the documentation in the governance portal, that will then generate a configuration file that gets pushed to the processing engine that will allow it to pull it in. So it's basically, it's a quality gate.
Yeah. Without documentation, no data comes in. Plain and simple. Yeah.
It's the only way you can get developers to write documentation.
I know, I've tried. Question.
I wanted to ask an organizational question, right? So one of the challenges that we have in our organization is getting, those multiple silos all in a line and doing this. And so I'm kind of curious if you could speak to, organizationally how you got all those people in line to do the work that they needed to do because when it doesn't impact their products, right? It's not,
So how did we get all the teams that are generating the data to document it and to clean it up? And I'd say in general, most of it has been driven by, at least as an overall initiative, just standard program project management type of principles. But in particular, setting the value, describing the value with senior leadership and saying, hey, this is why this is important. This is what it's going to enable us to do. And as we talk about some of the key benefits here, that's really been the first shepherd of the process has been, hey, we need clean data. Otherwise, we're going to get bad results. And in the nature of our business, where we need very high precision in many cases, because we just have so many devices out there, we really need to understand all the nuances. That's kind of how it came out. So we do put a lot of the onus back onto the core teams or the product teams that are developing that data. But we kind of have to do a name and shame type of approach of saying, hey, you guys are the ones that are not in alignment or not compliant with your event documentation and so forth. And then that goes out weekly to the entire leadership team. And eventually you'll see the first time we pushed that out, there was very little movement. The second week and the third week, they started going to town because they're like, oh no, my name's at the top of the list in red. And so just some typical kind of approaches to motivate. It's like, I want my name to be green.
Sure.
So.
And one second question. You talked about data quality and all the validation, and so I was curious if you could speak to the process of, you fixing that data and pushing it back into the pipeline, especially when you think of like real-time streaming and event hubs where, hey, I pulled this data off, now what do I do? Do I push it back into event hubs to push it, back into the system?
So how do you process it after you pull it off the stream for the first time? Talk about that.
Actually, if you want, we can chat afterwards and go into a little more detail, because that's probably going to chew up the last 7 minutes. I'll catch up with you right afterwards.
Find us outside after.
Yeah.
Question?
Yeah, Symantec employee here. I'm trying to copy and paste your architecture. I was a little confused. What's the point of the Azure Data Lake store? Why don't you use just like DBFS with the Delta format on like blob storage? Is that where you're storing all the data?
Yeah. Well, with ADLS Gen 2, it is basically blob storage. Microsoft has amalgamated the two. So it is basically just HDFS raw storage under the covers.
Yeah, and it's cheap.
So do you capitalize on like the JDBC connectivity to the Databricks cluster itself?
Yeah, absolutely. Like that's how Tableau, Power BI, that's how they connect in.
Okay, so it just...
Yeah, it just works.
Okay.
Question?
For the data catalog and lineage, right? So are you using any open source internally, or is everything custom built?
So how are we building the data catalog and so forth?
Yeah.
And
take
data
that.
lineage,
Yeah.
right?
Yeah.
So because is it start from ground up and everything built
Yeah.
portal custom, and
It's-
there are some products available in the
Yeah,
market?
it started from the ground up, proprietary. In reality, we started looking at different options in the field and didn't find one that fit our use case. So, at the beginning, we were using Excel to track, which was an absolute nightmare. When you have, 25 different teams sending requests and sending changes and going back and forth, that's why I have gray hair now. So this was, the original conception of this was throwing it at an intern for 4 months, and they came back with a V1. And that's what interns are for, right? Innovation.
So are you planning to open source this?
Down the road, I could, I can't speak to the company, but McAfee does give back to the community for this sort of thing. So, when something like this matures, I could see the underlying technology that it could possibly happen. But again, that's personal opinion, not McAfee opinion.
Sounds good.
Disclaimer.
Yeah.
And also another point around data cataloging and so forth. What we've observed looking at different solutions in the market is that essentially from your gold tables, if we call them that, or your platinum tables, that they tend to be very good at downstream of how data is used from there, but many times have a bit more of a challenge of where did that data come from.
Exactly.
And so
That's the lineage
that's
part.
where we focused first, was how does the data come to be, and again, simple solution of if you just generate, here's how we're going to do it, then you can generate a view of how it was processed. So,
Sounds good.
yeah. Question?
Hi. So when you were talking about the validation and the data quality, how did you collect all these validation rules for each attribute?
How do we get the validation rules for every attribute?
Yeah.
Very painfully.
So you actually put it in the data catalog saying this attribute, these are the possible best
We
values.
crowdsourced all of those rules and said, hey, you have to have them, and your name's not green until you have all of your validation rules set.
It was also the onus on, if you want to have the data, you need to have the configuration in the system. So it was basically an iterative approach. We crowdsourced who owns the events. Once we got owners assigned, then we iteratively went back and said, okay, we've got all these events, what do they mean? And then we iteratively went back a third time and said, okay, these are the attributes you're sending, what do they mean? And it's on an iterative approach, we've gone through, and if you want your data to flow, you need to fill this in. Because if we get to the next quality gate and you haven't documented it, you're going to lose your data. Yeah. It's a great way to motivate people.
Yeah, so crowdsource internally.
Yeah.
Okay, awesome. Next question.
It's good to know like the configuration and data lineage is the process you guys are adopting.
Sorry, can you
Can
move
you get a little
closer?
closer?
Oh yeah, is it good? Okay. So how you see the timeline when you get the request for the brand new data set, right? So in order to do the configuration and getting the schema and getting the configuration right and building up what are the validation you need to perform level 1, 0, 1, 2, whatever it is. Yeah. And at the end, they want to see the value out of that data, right? So what kind of time frame you basically look at that and how you buy that time from the whoever is going to be the business user?
So I think it's how long does it take to get new data sets pushed out, and then how do we handle holding off the lions so they don't come eat us? You want to talk about?
Yeah, so the one thing we've done is we've set up a separate QA environment where the data can flow in so they can see the data coming in that doesn't have the governance applied to it, so that that initial data set can come in, they can see the data set. However, the configuration, it's a self-service configuration. So when someone requests one of these, they can go into the portal, fill in all of the information, all of the details, submit the request. Someone on my team or our data steward is going to go through and validate all the boxes are checked that it's hitting the quality gates. Once that's done, it's 5 minutes. Because the configuration files are generated, it gets it's basically a push to git, deploy, run.
Yeah, creating the configuration is the most painful part. After that, of course, we'll have like the automated process will take care of that.
But it motivates people to write the documentation, because anytime we've had complaints about you guys are taking too long, the response is we're taking 5 minutes longer than it takes you to document it.
Yeah, and I have one more question regarding the pipeline processing.
Yeah.
So I see like you are using like Azure Databricks and Data Factory for your orchestration purpose. So I only see like Databricks is announced their partnership like 1 year ago. But how you guys did this one before that? Are you guys doing this one like 1 year old, or is this process is like a 2 year, 3 year old? How that previous one look like?
Yeah. So how did we get this stood up, or when more precisely? It's something we kicked off about a year ago.
Okay.
And really built it out through last year, and have gotten to a point where we're iterating and improving on it.
Okay.
Yeah.
And what are the challenges you had when you are doing with the Data Factory and the Databricks notebooks, or whatever the Python or other libraries you're calling?
So what challenges did we have with ADF and with Databricks jobs? If you want to talk about those.
Actually, we're out of time, so let's go to the back
We'll
of
have
the
to
room.
take it to the back. Thank you so much, everybody.
I'm sure, please give a round of applause for all the great things shared today. So.